This past week, we spent some time looking at science and pseudoscience. So in this video, I just kind of want to do some recap. This is a course on the philosophy of science. So we're not doing science. Rather, we're sort of standing above science and looking down upon it, asking ourselves, what is science? And what are its methods? What are its commitments? What are some of the problems and challenges and debates facing scientific practice? One of those debates is about the very concept of science. What is it for something to be scientific? So we began the course out by looking at science and pseudoscience. Pseudoscience is, simply put, fake science. It's not the real deal. It doesn't quite meet the bar of science. The more technical way of describing this debate is the demarcation issue. So to demarcate is simply to define the boundaries or limits of something. So when we're wrestling with the concept of science and trying to demarcate it from other things, we're trying to find out what the characteristics are, the qualities of science that make it different from other types of disciplines or other types of academic practices. And this is valuable because science has a strong influence in our culture, and it has for a long time. A lot of people think that science is the torchbearer of truth. If something isn't scientific, then we're more reluctant to give it a lot of weight in informing our beliefs. So science is really a really important phenomenon in contemporary culture, and we need to kind of figure out what exactly it is. There's also, I guess, political consequences of understanding what science is. Maybe not just political, but educational. So as you're going to learn this week, there have been some debates about whether or not creation science or creationism should be taught in public schools. So creationism is the only position trying to, well, it's not the only position that's of interest here. There's also intelligent design, evolutionary, creationism. Those are different. But in any case, there have been various debates about whether or not, say, some sort of creation hypothesis should be taught alongside evolutionary theory. And the response is often this: well, no, it shouldn't, because it's not science. So only scientific things should be taught in the science classroom. And so that really raises this question all over again. Well, what is science in the first place? We might ask ourselves, how is science different from other disciplines or activities? For example, religion or theology, mathematics. To use some more mundane examples, birdwatching or soccer. So what makes science different and unique? There are different ways to answer this question. For example, we might answer it by talking about the scientific method. Science is different in virtue of the method it uses to study the world. And if you've ever taken a high school science class or a science class here at Western, the semester usually starts out by discussing the scientific method, which goes roughly something like this. You go out and make some observations, then you ask a question about those observations and form a hypothesis. And then once you have a hypothesis, you just test it. You go out and make more observations. You create experiments to test your hypothesis, and you just keep repeating this. And eventually, hypotheses that continue to survive the tribunal of experience become theories. So that's sort of like a rough caricature of the method. In this class, we're going to explore more of the scientific method, but I think you'll discover that it's not quite as simplistic as it's often portrayed. We're going to talk about explanatory reasoning. We're going to talk about confirmation, falsification, some really fun issues, and some of the puzzles and challenges facing those things. Alternatively, you might say that what makes science different, what demarcates it from other things, is the objects it studies. So it's often said that science studies the natural world or the physical world, empirical phenomena. So science is different than, say, theology, than religion, than other kinds of pseudoscience. Why? Because it studies things like protons and electrons, black holes, planets, the galaxies, and so on. Lastly, you might think that science is different from other disciplines because of its goals. So what might the goal of science be? Well, it might be that science is interested in explaining the physical world or explaining aspects of the physical world and in predicting how the future is going to turn out, predicting human behavior or the behavior of atoms and so on. So I kind of want to make a point about this. Often people will say something like, science just describes the natural world. But that's not quite right. I mean, historically, science has been interested in explaining the world and in predicting, making predictions. So it's not enough to just describe what we see. We want to explain it. So maybe the goal of science is to explain the world, but not just to offer any kind of explanation, to offer a certain kind of explanation, perhaps a naturalistic explanation. So theology or religion might be interested in explaining the physical world as well. So the object of study for, say, theology and science could be the same. What's different, however, is the type of explanation or the goal of their inquiry. Whereas theology might be interested in a supernatural kind of explanation, it might be that science is uniquely concerned with a naturalistic explanation. So again, there are different ways to try to answer this question. We might appeal to methods, we might appeal to the objects of inquiry, or to the goals of the inquiry. And probably all of these are relevant to answering the question, what is science? This past week we looked at two different philosophers who have attempted to address the demarcation issue. Each of them describing a set of conditions, or at least some properties or qualities of science that make it different, make it uniquely science. One of those guys was Karl Popper. So according to Karl Popper, scientific theories have to be falsifiable. What does it mean for a theory to be falsifiable? It means that in principle, there's a way to show that it's false. It doesn't mean that you will show that it's false. It doesn't mean that it is false. It just means that the theory makes itself open to being false. So there's the possibility that it could be shown to be incorrect. One way to get a falsifiable theory is to construct a theory that makes risky predictions. I mean, think about it. When you make a prediction, you describe the world as a certain way. You say, this is how things are going to turn out. This is what you'll go and see and discover. And so there's the possibility that things won't be as your theory says they are. You could be shown to be false. And so theories that make risky predictions are falsifiable theories. So according to Popper, science should be concerned with falsifiable theories. That's what makes science different than other kinds of disciplines. And so what we're interested in science is creating conjectures about what the world is like, and then attempting to refute those conjectures. We subject them to experimentation. In fact, Popper thought that science wasn't concerned, or shouldn't be concerned at least, with confirmation and trying to support a hypothesis by getting a whole bunch of evidence in favor of that hypothesis. To make a long story short, he didn't think that we could actually get evidence for a hypothesis. This is the result of the problem of induction. Can induction get us to the truth? Popper didn't think so, or at least he didn't know how we could prove that. So his response to this was just to say, what we're interested is in conjectures and refutations, trying to refute our theories. We may not be able to show that they're supported by the evidence, but we should at least try as best we can to show, we should try as best we can to subject them to experimentation. And it might be that they continue to survive all these tests. That doesn't tell us that they're more likely to be true. It just tells us that thus far they have been corroborated by the evidence. They haven't been falsified. So the next philosopher we looked at is Thagard. And Thagard has a more nuanced approach to the demarcation issue. In fact, Thagard thinks that Popper's criterion of falsifiability is too simplistic. It just doesn't quite capture what science really is. It may be a part of the story, but it's not the whole story. So, like, Popper has a very strong and a very, restricted view of science. Science is concerned with falsifiability. We make conjectures and we try to refute them. And if a theory can't, in principle, be falsified, then it's just not even scientific. It has to make risky predictions. Thagard thinks that this is too simplistic and too narrow. Moreover, as we'll learn in week 3, falsifiability is a complex issue. It actually faces some problems. So according to Thagard, science involves 3 elements: theories, communities, and historical progress. So naturally, science involves claims and hypotheses about the world, claims that sort of try to get at the fundamental structure of things. But it also involves people who are making those theories. And so science should be a community thing, where you have people working together to develop theories, to experiment theories, to propose new theories. And then this feeds into the third aspect. For Thagard, science is a historical thing where you're trying to make progress over time. It's not enough just to land on a theory and be content with a theory. If that's what's going on, Thagard thinks you're not being scientific. Science is concerned with progress. So we want to look at the theories we have and ask ourselves, can they be improved? Or we might ask ourselves, are there other theories that do a better job at explaining the available evidence? And so we try to modify, we try to disconfirm, we try to experiment, we continually try to make progress and broaden the horizons of our understanding. That's science. It involves theories, it involves communities working together, and it involves progress. So if you become stagnant, if a theory just becomes stagnant, it's not yielding new insights, if it's not being tested, if it's not being modified, if it's not being compared to other theories, then it ceases to be scientific. So Thagard notes an interesting implication of his view. On page 229, he states, "One interesting consequence of the above criterion is that a theory can be scientific at one time, but pseudoscientific at another." So you can imagine that at some point in the past, the Aristotelian model of the solar system, or Ptolemy's model of the solar system, ceased to be experimented upon. No one was thinking of additional theories that might challenge it. The theory wasn't yielding new insights. So people were just sort of content with it and just stopped pursuing further research into it. According to Thagard, that theory is not scientific at that moment of time. But then imagine that at some point in the future, people start to think about the Ptolemaic model again, and they start to compare it to the Copernican model. And you have people like Galileo coming along and thinking about it and offering challenges to it. At that point, the Ptolemaic model, because it's involved in scientific discussion and debate, and people are wrestling with it, at that point, it becomes scientific again. So what's really interesting about this view is that what counts as a scientific theory depends on how people are approaching the theory. So science is relative to communities. It's relative to the work those communities are being done. It's relative to the attitude people are taking towards a particular theory. I have some things to say about this in one of the discussion areas. But maybe Thagard is right. Maybe there's a community aspect to this. There's a historical aspect to this. If we're not making progress, if we're not challenging a theory and trying to broaden its horizons, then maybe it ceases to become scientific. In any case, these are just some of the proposed answers to the demarcation issue, and there are many more. In the coming week, we're going to look a bit more at this issue. In particular, we're going to start to focus in on science and religion. It's really fascinating stuff, and I look forward to discussing it with you.